Hello. Yeah, yeah, of course. Yeah, it's good afternoon here. And it's just good morning early for you there, isn't it? So I had your breakfast, tea, is it all done? Okay, how this morning feels to you? Is it good? Are you happy today? Yeah. Yeah, me too, I'm fine. Yeah, it was a pleasant morning. I just woke up early in the morning. I just do my things. And after I just take a good nap, is a power nap of 2 hours. Yeah. Yeah, usually power nap will be of 10 to 20 minutes or half an hour, isn't it? But I took a power nap of 2 hours. I was so tired that I don't know what happened to me. Or while I lie to bed, I just get a good nap. Yeah. Yeah, of course. So, shall I move to the topic? Shall I share my screen? I think your voice is breaking. Will you please rejoin once more? Is it fine for you? Yeah, of course. Okay, I'll wait. Hi. Okay. Is it fine now? Yeah. So shall I move shall I share my screen and go to the unit? Is it fine? Yes. No, actually, I don't have got any weekend plans for this weekend. But it's fine. Usually, as I do not have a daughter of 3 years old, and usually every Sundays after evening will be go for an outing. Yeah, this actually for having some fun at all. Yeah, we have. Yeah, it's not as compulsory. If we have any other functions or any marriage programs at all, it will be cancelled. Otherwise, if we're free, if we spend the whole time of Sunday in the hall, by evening we just go out, just to make her happy, have food from outdoors at all. Yeah, yeah, it's kind of spending some quality time with family, of course. Yeah. So shall I move to the topic? Is it enough for you to know from my part? Okay, then what about your weekend plans? Or do you have any weekend plans? Oh, yeah, yeah. The morning session is to sleep, isn't it? Yeah, most of them are like that. Yeah, morning session. Yeah, I also like to sleep, but as I do know, since we are living with my in-laws and all, yeah, I take good sleep of up to 8:30 and 8:30 and try to wake up only after that. Because Saturday we will be late to bed. Yeah. Yeah, we spend time together in the family. Just have some quality time with all the members of the family and all. Yeah. At late night we'll be ordering food. Yeah, it's like a celebration. Yes. Yeah. So shall I move to the chapter? Yeah, of course. So today we are going to study about probability. What's it? Will you please repeat it? Yeah, probability. So the basic concepts of probability is being discussed in the class 9. So let me go to this introductory part, of course. Yeah. Do you like probability? Why not? It's quite interesting. No, I don't force you. Actually, I'm not a fan of probability, but you should study this because it's an important topic in ninth, 10th, in your higher secondary grades, central, isn't it? Yeah, of course. So, by understanding probability, we will learn how to measure the likelihood of events. That is, if we have got for an event to be occurred, that is, I'm rolling a dice. You know what's a dice? Yeah, that Ludo, Snake and Ladder game. We will be rolling the dice, isn't it? It is having six numbers there: one, two, three, four, five, six. So, the favorable outcome means the probability of getting one is 1/6. We had total outcome of six. Favorable outcome is only one. So 1/6. Did you get me? Yeah, the thing that you studied in the last class. Okay. We have experimental as well as theoretical approach. Today I'm moving on with the theoretical approach. Okay. Yeah. Sample space and events. These are all the newer terms you should study or you should get an idea of it. Identity is the set of possible outcomes and the substance of this outcome. That is, sample space is the whole outcome. That is, we have an option to come 1, 2, 3, 4, 5, isn't it? These are the events. Yeah, of course. So the probability calculation on determine probabilities of single, compound, complementary, mutually exclusive, and independent events. For determining the probability of single event, it's very simple. But when it comes to compound events, it is little bit difficult. When it comes to complementary, it is getting more complicated. And when it comes to mutually exclusive, inclusive, and yeah, we should have some more broader idea on it. Yeah, of course. Yeah. Then probability calculations determine probabilities of single, compound, complementary, mutual. Yeah. Real world application. Yeah, it's being applicated. Yeah, it's very useful in our real life for getting how much chance. It's we're measuring the chance of getting an answer for this. Measuring the chance of getting an event, isn't it? That is, you have got your dad is coming from abroad today, and the chance of he comes to home is he can come or he can't come. He, we are not sure about it. Then it will be 1/2, isn't it? Yeah, that is, we have two events here. Can come, can't come, isn't it? Positive as well as negative. And can come 1/2. Similarly, can't come is also 1/2, isn't it? Yeah. So that is 50%, 50/50, of course. So we need some prior knowledge here. So I'm going to the probability theoretical approach part. So probability refers to the likelihood of an event happening, isn't it? Likelihood, how much chance for it to occur? That is, the how much chance or what's the probability of your dad to come back home today itself, isn't it? It's a measure between 0 or and 1. Yeah. Yeah, probability is always between 0 and 1, isn't it? 0 is dad didn't come. 1 is dad come. Yeah, it's a measurement of probability between. It's a measure between impossible event and certain event. Yes. An event is any outcome or combination of outcomes of a random experiment. For example, we are tossing a coin and getting heads or tails. So the event is getting heads and tails. I'm tossing a coin. We have got two events there. We can get either head or we can get tail there, isn't it? Yeah. Sample space set of all possible outcomes of an experiment. That is, we can get a sample space heads and tails. Yeah. Even means if we get head there, that is the event. Head by head plus tail. From the head and tail, we just got the even head there. Yeah. Yeah, it's an outcome or combination of outcome. Sample space means what all are the outcomes or what all are the events, what all are the things occurring there. Yeah. Favorable outcome, the outcome of an experiment that leads to the event we are interested in. That if a coin toss, if you're interested in getting heads, the favorable outcome is heads, isn't it? Similarly, if you are interested in getting tails, the favorable outcome is tails. Yeah. Or I said, we have experimental as well as theoretical probability. So today I'm going to deal with this theoretical probability. Okay. Yeah. Theoretical probability assumes that all outcomes are equally likely. Yeah. That is, if I'm tossing a coin, the probability of occurring a head as well as a tail is same, isn't it? They are fair. Yeah, they're fair because the chance of getting a head is same as chance of getting a tail, isn't it? Yeah. So, P of E, the theoretical probability can be calculated by probability of getting an event. P of E is equal to number of favorable outcome by total number of possible outcome. That is, if I'm opting for the head here, the number of favorable outcome is 1/2. Possible outcomes are two. That is, we can get either head or tail, and the favorable outcome is getting a head. That is 1/2, isn't it? Yeah. So they have given us another example here that of dice. Yeah, for a fair die, the probability of getting a 3 is, yeah, for a dice, the probability of getting 1, 2, 3, 4, 5, 6, everything is likely, isn't it? Everyone is having an equal opportunity to come when we roll a dice. So what will be the probability of getting 3? Yeah, one chance is only there. Out of how much? Total events, how much? How many? Yeah, 6. That's why we get the probability of 3 is 1/6. So let me ask you a thing. What will be the probability of getting 5 there? Yeah. When I'm rolling a dice here, and what's the probability of getting 5 there? Yes, it's 1 by 6 because, yeah, very good, very good. So you got the concept, isn't it, yo? Wait, is it easy now? So, what about the probability right now? What are you thinking? Yeah, it's surely it's an easy part. It's an interesting part. Yeah, if you got the concepts clear, it will be very much interesting, of course. So we have complementary events here. Complement for any event E, the complement E dash is an event that E does not occur. Yeah, I'll explain to the thing. Before going to the explain from to the definition. That's I'm tossing a coin here. The probability of getting a head is, yeah, yeah, 1 by 2. Yeah, your answer is good. So what's the probability of getting a tail here? 1 by 2. So let me ask you, what's the probability of not getting a head? Yeah, if the probability of not getting a head, we should get the tail, isn't it? We have only two options here. So it's 1 by 2 itself. Yeah, that's complementary even. That's we are just finding a dash by just relating it. That the total probability will be 1. 1 minus p of e. When we subtract it, we will get p of e dash. Okay. Will you please read that definition once more and just go through it and say me if it's okay for you or not. Is it fine? Did you get the concept there? Okay, they are very good. So, yeah, the same as a example I just explained to you. So let me ask you, thing. What's the probability of not getting three while rolling a dice? What's the probability? What's the complementary? What's the probability of not getting a three while rolling a dice? Yeah, we can just substitute it in the equation. That's p of e dash is equal to 1 minus p of e, and p of e is 1 by 6, isn't it? So 1 minus 1 by 6. Yeah, the answer is 5 by 6. Your answer is correct. Yes, dear. So the probability of not getting 3 while rolling our dice is 5 by 6. So you got that, isn't it, dear? Yeah, of course. I'll show it here once more. Sorry. Or any color preference from your part? Blue. Okay. So that, okay. We know that while actually the problem is this cursor is getting in which color? White color. So I can't follow it well in color. Yeah. Yeah, one not is more comfortable to me. So we have got a dice here and let me mark it as 3. Okay. So they are asking what's the probability of not getting E here? Sorry, 3 here. So we have the equation P of E complement or E dash is equal to 1 minus P of E. We don't know what is P of this part is not to us, isn't it? But we know what is P of E. This is equal to 1 by 6, isn't it? While rolling our dice, the chance of getting or the probability of getting 3 as the answer is 1 by 6. So what will be P of E? E dash 1 minus 1 by 6. That is equal to 6 minus 1. The whole by 6 is equal to 5 by 6. Isn't it? Yeah, you got the answer. Is it clear to you? Okay, of course. Thank you. Yeah. So we have simple probability problems. Yeah. Shall we discuss this one? Problems involving simple experiments like rolling a die, flipping a coin, or drawing a card can be solved by applying the basic probability formula. So in the we have got a bag which when it contains 4 red balls and 1 blue ball, the probability of drawing a blue ball. Will you please say me what's the probability of drawing a blue ball? Yeah, 1 by 5. Yeah, because the total outcome is 5, isn't it? And favorable one is just only 1, so 1 by 5. Similarly, what will be the probability of getting a red ball? 4 by 5. Yeah. Similarly, we can find that P of red complement or a dash, isn't it? Yeah, 1 minus 4 by 5. The answer will be 1 by 5. So it's clear to you, isn't it? Oh, okay, very good. So, probability, a theoretical approach. Probability is a quantitative measure of uncertainty. That is, we are measuring uncertainty that is going to happen in the future, isn't it? It's a chance. We are measuring the chance here. We're not sure about it. Yeah, it predicts how likely an event is to occur, and the probability of an event is found by performing an experiment multiple times and recording the occurrences. It's based on observation and past data. We are coming to a conclusion in this part by just doing that experiment again and again. We just repeat it. Okay, then we are just coming to conclusion that is we know that when if you roll a dice, we are getting six outcomes, isn't it? How did you know that? Because we just experimented before. And we know that if you roll a dice, there are only six possible outcomes, and there are one, two, three, four, and five, six. And for the favorable outcome, if we are opting for three, that the probability will be 1/6, isn't it? Yeah, by doing several experiments before, we just come to a conclusion here. It's based on observation and past data. Did you get that? Yeah, so we are dealing something about coming in the future, isn't it? Uncertainty, of course. So theoretical probability predicts outcomes without actually performing the experiment. Yeah. Here actually we are find the probability in such a way that what's the probability of getting a three while rolling the dice? Actually, we have not rolled the dice. We are before going to the case or before going to the game itself, we are finding its probability. Okay. It's based on logical reasoning and mathematical calculations. Yes. So we have some basic terms in probability here. Outcome. An outcome is the result of a single trial of an experiment. Okay, outcome. What's the result we will get while doing an experiment? In the single trial, this one trial, okay? Experiment is an operation that produces well-defined outcome. That is, after the experiment, we will be getting well-defined outcomes. Sample space is a collection of all possible outcome of an experiment. That is, while rolling a dice, its sample space is 1, 2, 3, 4, 5, 6. If it is a coin tossing, it will be sample space will be head and tail. Okay. Yeah. Equally likely events. Two or more events that have equal chances of occurring. So, experimental or empirical probability. I don't want to go to this experimental probability today because I don't want to make you more confused. So, today we just deal with only theoretical probability. Okay. Yeah. P of E is the number of favorable outcome and total number of possible outcomes. Quite easy, isn't it, dear? So, we have got an example here. What's the probability of getting an even number on a time? Yeah. So, the possible outcomes are we can get either 2, 4, or 6. Isn't it? And what's the total outcome there? Yeah, 6. So 3/6, 1/2. Yes. Did you get that? Is it 5? Okay, yeah. So number of outcomes favorable to E divided by number of all possible outcome of the experiment. That is favorable outcome divided by possible outcome. That is P of E. The same thing is we are repeating here. Creative flash convert is simple P of E. Yeah. Do you know about the cards? Do you like to play games? Card games? No, I'm just asking about the deck of cards with king, queen, ace, jack, a heart, spade, black and red cards, diamond, clam. Yeah, do you know about it? Yeah. So you love to play indoor games also. Is it like that? Very good. No, I'm not. I'm not a fan of playing cards. Actually, I don't play it in my childhood or not. But I'm a fan of outdoor games. I just like to play badminton, football, cricket, and yeah. I'm a fan of outdoor games. Yeah, I like to spend more time in the outhouse. I'm thinking about my childhood days. I'm the one who is more ready to just go to every home and call every child. Get out, we can play, we can play. Yeah, I was type of that. Yes. So we have comparison of probabilities and also let me go to a question today, and I don't want to make your class more long. Okay, I don't want to make you more boring. So, two coins are tossed simultaneously. Find the probability of getting exactly one hit. So here, there's something different. Yeah, it's here the sample space is becoming two. Yeah. So two coins are. Oh, I'll go to your red color. Which color you need? Blue. Okay. Two coins are tossed simultaneously because that means Here, you and your friend is chosen two coins at a time. Okay. And we had two options here to come, two solutions here to come. They can be head, head and tail. And as well as the next coin also, the same outcomes are here. That is head and tail, isn't it? Yeah. So, to coins a toss hammer, find the point of getting exactly one hit. That means one should be head and other should be tail. So let me write all the possible outcomes here. Yeah, possible outcomes are we can get head, we can get head and tail, we can get tail and head, we can get tail and tail, isn't it? Yeah. Head on both the coins, head on first coin and tail on the second coin, tail on the first coin and head on the second coin, tail on both the coins. Hmm. So these are all the possible outcomes. We have four possible outcomes here. And what's the favorable outcome here? Favorable outcome is getting a tail. Favorable of getting exactly one head. Okay. Isn't it? Exactly one head. That means we had two possibilities here. That is HT and TH. So that is two. Number of favorable outcome is equal to two. So I'm just substituting it to the equation. Equation is P of E is equal to number of favorable outcome by total outcome, isn't it? Yeah. Equation of theoretical probability by total outcome is equal to 2 by total outcome is 4, so it's equal to 1 by 2. So did you get that? Okay, is it fine? Okay, dear. So shall I stop my class for today? Is still here? Is it all clear to you? Yeah, I don't want to make you more fuzzy with this probability topic. Of course. So we can continue this in tomorrow. Of course. So shall I leave now? Okay, dear. See you tomorrow. Take care. Enjoy weekend. Bye. Okay.